So in this chapter, we will talk about stoichiometry, which is one of the most important aspects in chemistry because it deals with quantities. And so you can find out how much to start with, how much to finish, so many other things. So let's get started. So let's first talk about what stoichiometry is. Okay, and stoichiometry is a lot of calculations in which you try to figure out many different things. Okay, so for example, if you have a certain amount of product in mind, then how much starting material would you require to produce that product, or how much a product will be produced if you have a certain amount of starting material. Will that reaction be affected if there is more than one starting material? That will be dealt in what we call limiting reagent problems, where if you have more than one starting materials, then what happens? Then will there be any starting material left over? So for example, in the third point, where we have more than one starting material, then do you have anything left over, or does it all get consumed? And then finally, how efficient is the process? Okay, which means that what is your percent yield? Is it a good reaction? Okay, all of these things, by the way, as a consumer, this is a very important thing because this drives the price of any kind of product that you are trying to buy. So if your process is more efficient, then the cost of production goes down. If your process is not efficient, then the cost of production will go up. And the consumer, of course, will end up paying off everything. All right. So it's really a very important part of chemistry. Then how do you do stoichiometry? And one of the most basic things that you start with is a chemical reaction. And a chemical reaction is a representation of chemicals in a reaction. So the reaction will be written in chemical symbols, so you can clearly see how many atoms are being involved here. If you just write the name of chemicals, then you really cannot see how many atoms you have, because if you remember, when you have main group elements, you really cannot see how many different atoms you have in there. So this is how you would write a reaction in general. So you have reactants on the left side and products on the right side. This arrow over here indicates yield. We never have an equal sign over here because reactants are never equal to the products, because reactants are different than the products. If you have an equal sign, it means that the things on the left are equal to the ones on the right, which they are not. Okay, and so you have to use an arrow, okay, for writing reactions. So chemical equations, this is the first thing to deal with when we deal with stoichiometry. So again, reactants, yield, products. So let's write a simple chemical equation and see how what are the different factors that we need to look at. Okay, so for example, carbon, adding on oxygen to give carbon dioxide. The first thing you have to remember is that the law of conservation of mass has to be obeyed, which, if you remember from Dalton's atomic theory, states that in a chemical reaction, atoms will rearrange, nothing will be created, nothing will be destroyed, which means that the number of atoms you have on the left-hand side should be equal to what is on the right-hand side. So number of carbon atoms here in this equation is 1 on the left, 1 on the right, and 2 oxygen atoms on the left and 2 oxygen atoms on the right. Okay, so matter is conserved over here. Now, of course, it will happen that the atoms may not remain in their original form, which means that there is a chemical change involved here. When you have carbon on the left side, this carbon is not the same as the carbon with the oxygen that is bonded to the oxygen. So that is a different thing. Okay, so the elemental state may not be the same, but the number of atoms are all there. Okay, and finally what we look at in an equation is that if it's balanced or not, and this is exactly what we do, is we count the atoms on the left hand side and the right hand side of the equation to make sure that we have the right number of atoms or the equal number of atoms on both sides. Okay, so this is called balancing of an equation. Here is an example of balancing an equation. So writing a reaction between sodium and chlorine to produce sodium chloride. Okay, so the first thing you have to do is you have to figure out the formula, okay, for each of the compounds over here. Sodium is an element, okay, which is just Na. Chlorine is Cl2, and this is an important part because if you remember, we talked about in nomenclature that there are about 7 gases on the periodic table that are diatomic gases. Now, when we talk about chlorine, oxygen, nitrogen, iodine, fluorine, bromine, all of these have to be written as diatomic, and hydrogen. They all have to be written as diatomic gases. So when we say chlorine, we don't mean just Cl, we actually mean Cl2, okay? That is something you really have to remember, because this is one thing that almost everybody misses when writing reactions out. So sodium is Na, chlorine is Cl2, and then sodium chloride is NaCl. And again, this is coming from nomenclature that we learned about ionic bonding and how you have a neutral compound, Na is +1, Cl is -1. This is something that you should be able to write now. So then we go on to write the chemical equation, all right, which is Na plus Cl2 to give NaCl, all right. Next, you check the number of atoms on each side of the equation. So sodium is 1 on the left side and the right side. Cl2, however, is not. Okay, so chlorine is 2 atoms over here and only 1 atom on the right hand side. So these 2 atoms are not one of these atoms of chlorine is not accounted for. Okay, and so we have to take care of that. And the way we do that is by balancing an equation. Okay. And what we have to end up doing then is we end up inserting what is called a coefficient, and the coefficient is always added in front of the chemical. Okay, so you don't just add a 2 after the Cl, because that will change the formula to NaCl2, which is an invalid formula. Okay, that does not exist, so you cannot have that. All right, and so you have to add numbers in front of the compound, and that's how you change the number of atoms in any formula. This way you don't change the compound, okay, itself. NaCl still stays NaCl, you just have 2 of NaCl now. Okay, so now when we look at this equation, you have 1 sodium atom, 2 chlorine atoms, 2 sodium atoms, and 2 chlorine atoms. So now the sodium is not balanced because you have 2 sodium on the right hand side but only 1 on the left hand side. So to balance the sodium, we insert another coefficient, and this is a 2 before sodium, okay, because we needed to have 1 more sodium atom on the left hand side in order to balance this equation. So now we have 2 sodium, 2 chlorine, and then 2 sodium and 2 chlorine on the right hand side. This is balancing an equation. So you take it 1 atom at a time and then balance the equation. So as you saw from the previous slide, we were actually talking about writing chemical equations, and it is very common, at least for me, that you have to be able to write a symbol equation from a word equation, which means I'll give you a word equation and you have to write the chemical symbols for it, like you saw in the previous slide with sodium chloride. So that's a very common thing. So first of all, you should know all your symbols. Second thing is you should know your compounds. And of course, third thing is that you should know what is the reactant and what is the product. Okay, and so here are the hints for writing chemical equations. First of all the metals will always be monoatomic. So group 1, group 2, group 3, and then the bottom elements and the transition elements. Those are all the metals. They will always be monoatomic. So potassium will always be K, tin will be Sn, and there is no other number in front of it until you're balancing the equation. So potassium is not K2 or 2K, it's just K. Then there are some elements which exist only as diatomic gases, which you know from chapter 2 I gave you. There are 7 of those. So chlorine and all of the group 7 halogens, all of them are diatomic. So you will always write chlorine or fluorine as Cl2, F2, never as just Cl. Oxygen and hydrogen are other 2. And then there's the nitrogen, of course. Okay, those are all diatomic gases and always written as O2, H2, not 2H or 2O. Then all the compounds should be written in their proper mole ratios, so which means that they should have proper bonding and balancing out of the charges. So sodium chloride is NaCl because Na is +1 and Cl is -1, and so this to be a 1-to-1 ratio. Whereas for calcium chloride, it's going to be Ca2+, and so you need 2 chlorines to balance that out. So it's CaCl2. So you have to be good in nomenclature in order to be writing all these equations. And then the last part, of course, is to, when you read the problem, you have to figure out what the products are and what the reactants are. Okay, and then of course all of these things come only from practice, so make sure you practice.
So here is an example, okay, of writing an equation. So write the equation for magnesium reacting with nitrogen to give magnesium nitride. So the first thing I would do is write all the elements out, okay, all the chemical symbols out. Magnesium is Mg, nitrogen is N2, and then magnesium nitride is Mg3N2. And of course, the next thing is to put them in a chemical reaction. So which means you need to know what is the reactant and what is the product. So you read the equation and it says write the equation for magnesium reacting with nitrogen. Reacting with means they are together to give magnesium nitride. To give means that is the product. So then here is our equation, magnesium plus nitrogen to give magnesium nitride. And then of course I can write the symbols out because I've already done that. Now here is a nice example for you to see, because here is magnesium written as Mg and nitrogen written as N2. The words don't tell you how many nitrogen atoms you have. You see that only when you write a chemical equation as an N2. Otherwise, you will think nitrogen is probably just N, which it is not. And the same thing goes for magnesium nitride. You might just write MgN, which it is not. Okay, and so it is a ratio of 3:2 in the chemical formula. So be careful, know your nomenclature, and write the equation properly. And then, of course, the last thing is to balance the equation. In balancing the equation, the best rule to follow is whatever symbol is by itself, whatever element is by itself, you leave it to the end. Okay, that's the last thing to be balanced because it's by itself. If you put any number in front of it, it's not going to change anything else. So the best thing to do is to balance something else first. So in this case, of course, we have nitrogen, which is diatomic, and here is nitrogen as in N2. So I will take this N2 and then put it in front of the 2 over here for nitrogen. That gives me 4 nitrogens here and 4 nitrogens here. And then, of course, I have to see how many magnesiums I have because I've changed the number of magnesiums. And that becomes then 6. 2 times 3 is 6. So that's 6 magnesium and 2 nitrogen to give 2 Mg3N2, which is magnesium nitride. Okay, so that is how you would balance the equation for this. And please learn how to do this. Practice, practice, practice.
Okay, so in this case, you have another equation given to you, okay, which is CS2, which is carbon disulfide, plus oxygen to give carbon dioxide and sulfur dioxide. I have one little trick for you if you want, and this is a very good practice to do when you're writing equations, is to call them by names, okay? Don't just say it by symbol. So don't say CS2 plus O2, don't say that. Go ahead and say the name of the compound. That way you get to practice your nomenclature as well, okay? So do both the things. So balance this equation. So first of all, you tally all the numbers of atoms on each side of the equation. So carbon first, 1 on the left side and 1 on the right side. Sulfur is 2 on the left and 1 on the right hand side on the product side. Oxygen is 2 on the left side and 4 on the right. Remember, 2 from carbon dioxide and then 2 from sulfur dioxide. So here's a misbalance here also. So you can start wherever you want. In general, the goal really is to leave all the elements, okay, to balance out at the end, okay? So that way you don't have to worry about changing all the other compounds, okay? So leave oxygen for the end because it exists by itself. If you change the number of oxygen, it will not affect anything else, okay? But if you change the number of oxygen here, it will affect sulfur also, okay, on the left hand side. So these elements, leave it by itself and do the compounds first, and you can choose whatever you want. Carbon is 1 on the left hand side, so you no need to start from carbon. You start with sulfur because sulfur is 2 on the left hand side and only 1 on the right hand side. So you start with sulfur and go ahead and insert a coefficient in front of sulfur. Okay, so once you have that, then you go ahead and balance out all the atoms again. And now we have sulfur, which is balanced out, but oxygen is 2 on the left. And now we have 6 atoms of oxygen on the right hand side. Okay, so oxygen is obviously highly misbalanced. Okay, and so then we go on to the left hand side and we put 3 in front of the oxygen. All right, and so now you have 6 oxygen atoms. 3 times 2, that's 6 oxygen atoms here, and 2, and then 2 times 2 is 4, so that's a total of 6 oxygen atoms on the right hand side. We did not have to do anything with the carbon, so carbon is all balanced out. Okay, it was only the sulfur and oxygen that we had to worry about. So you take it step by step when you balance any equation out. And again, remember, leave the elements, okay, for the end. Don't do it in the middle. Finally, one last time, okay, just give it a quick check and make sure that all your atoms are balanced, okay, and this is called balancing an equation. Here is another one that goes in detail about balancing ammonia with oxygen to give nitrogen monoxide and water. Okay, so I'm going to leave this for you to go through one by one and balance it out, okay, and see if you can do this. Okay, all the instructions are over here, so I don't have to talk through all of this. Just read it through or go ahead and balance it yourself and then check the final answer, okay, for you. So let me just go ahead and give you a quick overview of this instead of reading all these little instructions over here. Nitrogen is 1 on the left, nitrogen is 1 on the right, hydrogen is 3 on the left and 2 on the right, oxygen is 2 on the left, and oxygen is 1 on the right. Again, oxygen is an element over here, so I'm going to leave that for the end. Okay, so I will start with the hydrogen. Hydrogen is 3 here and 2 over here. Okay, and so the best thing to do is do a cross multiplication. Okay, and so which is 3 over here and 2 here, so which means bring 2 on this side and take 3 on the other side. So which means that you have 6 hydrogens here and then 6 over here. I hope you got that. Okay, so again, if you have 3 hydrogens here, remember these are not equal multiplicants, okay, which means that they're odd numbers, all right, so they're not multiples of each other, so it's not like you can just multiply it by 2 or double or triple anything, so multiply it by each other, okay, so multiply the 2 hydrogen by 3 and multiply the 3 by 2, okay, to give you the 6 hydrogen atoms that you need. So once you have balanced the hydrogens, then you will balance out the nitrogens, okay, to make sure that your nitrogen will be balanced out, and then of course you look at oxygen at the end. Okay, so that's how you get started with this equation. Again, read all of this, okay, to figure it out. Let's look at the different types of reactions. These are covered more in chapter 4, but I'm going to do them now so that you feel a little comfortable with the different kinds of reactions. And so when I say something is a displacement, you're not completely at loss. Besides, it will make you feel comfortable when writing reactions out. Okay, and so there are 4 kinds of reactions. The first one is synthesis, or what we call combination reaction, in which case 2 starting materials will give you 1 product. So usually there are more starting material and less product. It could be 3 starting materials and 2 product, or 3 starting materials and 1 product. So you get the idea. In case of double displacement, there are 2 substances, and in both of them the cation and the anion will exchange. Okay, so for example, silver is a cation which will exchange with the chloride anion of sodium chloride. So silver nitrate plus sodium chloride go double displacement to give silver chloride and sodium nitrate, okay, at the end. So that's called a double displacement, in which you have only a single displacement is something like this, where you have zinc displacing copper to give zinc sulfate, and then the poor copper is all by itself. Okay, so this is a single displacement. A decomposition is when you have 1 starting material which decomposes to give you 2 or more products. Okay, so again, it depends. If you have 2 starting materials, you may end up having 3, and so on. Okay, so these are the 4 different kinds of reactions. The other thing I want to mention over here is this G, L, S, A, Q. So G stands for gas, L stands for liquid, S is for solid, and AQ is for something that is dissolved in water. These are called phases of substances. Okay, remember we talked about this in chapter 1. There are different phases. And the solid phase, for example, here, okay, this is a solid phase. So it indicates to you that the 2 sodium chloride that is being produced is actually solid. Here, these solutions are aqueous, which means that we have things that are dissolved in water. Sodium chloride silver chloride here is a solid, and that is not dissolved in water then, okay? And this is not a liquid. Anything that is dissolved in water is going to be considered aqueous. Anything that is in liquid state will be considered liquid, okay? So for example, water is a liquid. Water is not aqueous, okay? It's not aqueous. So water is a liquid. Anything dissolved in water is aqueous. So these are the three different phases that we have for writing reactions.
To review, you need to know all the chemical equations, which means you need to know what reactants are, products are, the state symbols, which is the solid, gas, liquid. Of course, you need to know how to balance the equation. That is going to keep coming up again and again, so better learn it. You have to be able to write a chemical equation from a word equation. That's something I've covered in this slide, and there are practice sheets also available to you. And then there are 4 types of the chemical reactions: the synthesis, double displacement, single displacement, and decomposition. Either I will say that this is a synthesis reaction, or I will just say these two are reacting to give this, classify the reactions, something like that. So make sure you do all of this stuff. Hopefully it's not too much for this little PowerPoint.